All right. Hello, Mariah. Hope you're having a lovely time on vacation. Or you're back from vacation or whatever it is. What's funny, is she not on vacation? She is, right?
No, your face.
Oh, yeah. I'm jealous. Okay, law of cosines. Okay, we're gonna start with just the basics of what law of cosines is. Okay, this is for any triangle. A squared equals b squared plus c squared minus 2bc cosine A. You can switch up these numbers any way you want, but it is important that if this is B and C, then that is B and C. And that if this is side A, that the angle that's in here is the one that's opposite that. This is used specifically in two circumstances: when you have side, 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 or side, angle, side. So let's do an example. Too good to be true. Mariah, I know you're not going to believe me, but I had an excellent triangle that I drew before. Ha! I can show you. Look at that. Proof. Ha, Mariah. Stop making fun of me all the time. I know she is. Okay. She's like the nicest person ever. That's a lie. This side's going to be 12.9 meters. This one's going to be 42.3 degrees. And this side will be 15.4 meters. Okay, now we're going to find all of the remaining sides and angles. Okay, what is easier? Law of cosines or law of sines? Yeah, I'd say sines, right? This looks like a mess. Doesn't this look horrible? So the idea here is that we're going to use, we can't do the combination, because if we said like the sine of C over that equals the sine of B over that, do you see how we don't have two things here? And if we did like the A in comparison, we also don't have side A. So we're missing something on every ratio. You see either a side or an angle. So we have, this is a situation where you have to use the law of cosines. Side, side, angle, side. Did I tell you about the time that that kid was joking about using law of cosines when he could have used law of sines, and it was such a waste of time, and everybody like died laughing, and it was super nerdy. Yeah, and then a kid was like, was there even an included angle? And he was like, no, and everybody like lost it, and I was like, wow, there's a bunch of nerds in front of me. My heart is like swole up 3 sizes from my Grinch heart. So let's talk about how to use this. In this case, it just so happens that I set it up with the B, C, and A, but that isn't always going to happen that A happens to be the one you're using. The cosine of A just happens to, the angle A happens to be whichever angle you have. Okay? So I'm going to write A squared, I don't know what A squared is, B squared, that's 12.9 squared, plus C squared, 15.4 squared, minus 12.9 times 15.4 cosine 42, hold on, 42.3, a 2 I missed? Yes. You're right. Go get a prize. It's a good day for you. Okay, now this is absolutely horrible, but do you see that even how horrible this is, that this whole right side is just numbers, which means we can put it into our calculator right away. So let's just try it together. All right, so you're going to type in 12.9 squared plus 15.4 squared minus 2 times, make sure you include that 2 or Michaela will get another prize, times 12.9 times 15.4 times the cosine of 42.3. And I'm assuming that your mode is in degrees right now and not radians. I got 109.7. But that doesn't make sense for this side. If this side is 12.9 and this side is 15.4, why is A 109.7? Right, because this is A squared equals that, so to finish it, you gotta do a quick square root. Technically, every time you do a square root, you should be saying plus or minus, but that makes no sense in the context of the side of a triangle. So just take the positive one, which is 10.47? Okay, now we have 10.47. How do I find this angle and this angle now? You could. I would not suggest using the law of cosines again. And remember that angle has to be in between them. If you could technically use the law of cosines, because you could use this side, and then say this one is the one we don't know, this angle is, and then do inverse cosine at the end, but it's messy and it's gross, so let's just use law of sines to get another one. So I'm going to do B here, so I'm going to say 12.9 over the sine of B equals 10.47 over the sine of 42.3. In my calculator, I'm taking 12.9 times the sine of 42.3. And then what should I do? Divide by 10.47. So I got that the sine of B is equal to about 0.8292. Did you guys get the same thing? Now what do I do to find out what B is? Inverse sine, so second inverse sine, 0.8293 or 92. Do you guys get about 56 degrees? Okay. How about how to find C? C you can just subtract from 180. Now, sometimes there's a short way to do a problem, and sometimes there's a long way to do the problem. For example, the kid that was just dying about using law of sines, imagine if it was this. Imagine if I said, try to find angle C, and you were just like, oh, subtract from these two from 180, I got it, and instead you chose to do inverse law of cosines. You would get the right answer. But mathematicians are lazy, so we're going to go the quickest way, okay? If I ask you to go to Weiss's room, it'd be smart to just walk right there and not walk down, touch the doorknob of Mrs. Sicking's room, come back, go around the square, and then go to Weiss's room. I mean, you'll still get there, but it's not worth it, right? So think logically when you're doing these problems about what the fastest way to do it is. But if you don't do it the fastest way, do you have to erase your work and fix it? No, you still got the answer, okay? But go ahead and be mad at yourself for a little bit, because you will be. I'm secretly hoping that it happens to Morgan at least once, because I love it when you're mad. I love it. You are my favorite person to be. Can you get a podcast, please, after you graduate high school? Because I would love to hear you yell about absolutely anything. You'll be like, let me tell you the problem with skunks. And I'll be like, what is the problem with skunks, Morgan? What is the problem with skunks? I'm going to agree with you. Whatever it is. I'm so, thank you. Tell me about it. All right. Literally, please tell me about it, Morgan. Hey, look, it's a lake. You can tell it's a lake because it looks so lakey. And we're trying to find this big O distance right here. Okay, so they've got a point A, and they've got a point C, and a point B. And they know that this side of the lake is 259 meters. and this side of the lake is 423 meters. So this angle in between is 132.7.